This is another of those was never meant to be a film that somehow turned into one. First, a bit of background. During my day job, I use syringes all the time to produce small positive and negative pressures for testing, calibration and fault finding. And they're really handy for applying sealants, lubricants and adhesives. They really have 1001 uses. The Common or Garden disposable plastic syringe comes with a lure fitting on the business end. Now there are other types of tip, depending on the particular application. But the male lure is the type that I come across day to day, and it's what I'll be concentrating on in this video. A bit like a Morse taper, a lure connector is another type of taper fitting. It makes a snug, self-gripping gas and fluid-tight connection that can be made and unmade quickly, without tools, with or without gloves. ISO standards govern the size tolerances, which means, by and large, parts made by different companies play together nicely. Out of curiosity, I tried to verify the advertised 6% or 1.72 degree taper angle. By my reckoning, 4 mm of horizontal travel along a 1.72 degree slope should give me 0.12 mm of deflection. I tried a bunch of different syringes, measuring tools and various fixtures on the mill and lathe. Even allowing for a bit of error on my sketchy setups, I couldn't even get close. I wasted a full afternoon messing about with this until the obvious struck me all at once. Knowing the taper angle was neither here nor there for what I was trying to do, so I gave it up as a bad job. Lure connections come in two main types, the simple push-on slip type and a locking type that has an internally threaded ring surrounding the tapered cone. The slip type is probably okay for a quick flu jab. But if you're infusing medication over several hours, you'd want the security of the locking type to make sure nothing can become accidentally disconnected. Sometimes, depending on what I'm up to, I'd really like a slip type, but there aren't any in stock, so I have to make do with what there is. You'd imagine just trimming the ring off the outside would be easy enough, but it's harder than it looks. In truth, it's not something I do all that often, but each time I do, I think I really ought to make a tool to make this safer and more reliable. So, onto the project. I had something along the lines of a cigar cutter in mind. The brief I set myself was that I only wanted to make it from stuff that I already had lying around the workshop, and preferably only from recycled scrap, rather than anything I'd paid pound notes for. I wanted the tool to work with as many sizes and brands of syringe as possible, so before I did anything else, I took some measurements to decide how big the hole in my cigar cutter would need to be. 10 mm is a nice round number, and it seemed like it might work with the existing hole in my brass disc. The plan was that a syringe with a larger diameter ring would comfortably pass through the 10 mm hole, and a guillotine blade that advanced 2.2 mm beyond the hole diameter would cut the ring whilst missing the central lure connection. And if I replace the larger one for one of the syringes with a smaller lock ring, the same blade position will still cut through the ring and still misses the central lure. A small problem was there was a rebate in the back of my brass disc that would stop me having a full thickness 10 mm through hole, so I made a plug to press fit into the hole from another bit of scrap. I'd been moving the disc between the lathe and the mill, so I needed a way to hold it in both machines. As it would be light cuts all the way, I went with the super glue arbor. I took a short piece of aluminium hex, drilled a clearance hole in the centre, cut a rebate to match the brass disc, added a few grooves for the glue, and stuck the disc in place. Once the superglue had gone off, I removed the spare material from the face. Then drilled and reamed a 10mm hole. Before removing it from the lathe, I just barely marked the jaw 1 position, so that I could rechuck it the same way round to try and minimise runout. So onto the blade. I plan to use a single-edge safety blade, mainly because a long time ago when I thought I was ordering a pack of 10, I ended up with 10 packs of 10, and they've been hanging around ever since. They're pretty light duty at only 1/4 mm thick, but I hope that would work in my favour by making them easier to push through the plastic. I thought the next thing would be to mill a recess to accommodate the blade, but in an unusual move, I actually thought more than one step ahead. It dawned on me that pretty soon I'd have to make the cover plate, and the cover plate would need a reamed hole in the middle, and a reamed hole in the middle would need the milling machine. So I put the brass disc to one side to concentrate on the cover. The cover needed to be relatively thin, stiff, not prone to rust and easy to machine. The closest thing I had on hand was an offcut of 0.9mm engraving brass. I drilled and reamed the 10mm hole before cutting out the circle, as drilling thin brass can sometimes be a bit exciting, and having a larger piece to hold on to would make life easier. For the same reason, I went up gradually from small to large with the drill bits. The scroll saw and I haven't really had a chance to get properly acquainted, so I'm well aware my technique needs work, but nobody learned anything by doing it right first time. The idea behind the 2 accurate holes was that I'd be able to use a tiny scrap of silver steel as an alignment pin. Over on the mill, I centred the hole, ready to drill the fixing holes that would hold the cover in place. I'd half planned to use brass rivets here, as when done carefully, they can be all but invisible, but I was conscious the tool would likely be used in a wet environment, and if the carbon steel blade was left in place for any length of time, it might get rusted in position. So I opted for tiny stainless M2 button head screws instead, the hope being that it could be dismantled should the need arise. Rather than work out the hole coordinates longhand, I sketched it out and let CAD give me the numbers. I spot drilled 7 points and then went round again to drill through 1.6mm, and then went round again with an M2 tap, cutting the threads using only light finger pressure. My blade is 0.25mm thick, so cutting a pocket 0.3mm deep seemed like I'd have enough room for movement. For my workshop, 0.05mm of clearance is a fairly tight tolerance. I didn't want to end up with a wedge-shaped cut, so I ran a couple of light fly cutter passes over the disc to help make sure the upper face was as true as possible to the spindle axis. I fitted a 4mm 3-flute cutter and set my depth of cut. My Z-axis has a DRO, but unlike the X and Y axis, I don't 100% trust it. I like to check with a mechanical gauge when I want to be certain how much I've moved. Once I cut the recess, I fitted the back cover and trimmed the back edge off. This took very many light passes, but it's only a small cutter with a fairly low spindle speed, and more importantly, there's only superglue holding it together. The final machining operation was back on the lathe, to remove the spare material from the diameter. A quick test, and all appears well. All that remained was to remove the arbor and tidy things up on some fine abrasive paper. . didn't want to just store it in a drawer as it was. The chances are I'd lose the end of my finger on the loose blade. I already had a bunch of screw-top tins that I'd ordered for my pewter magnet project, which I didn't use because they arrived looking a bit tatty. They'd be okay for this project though. All I wanted to do was keep the bits together and not have loose razor blades floating around. I made an insert for the tin over on the 3D printer. The insert houses a few spare blades and the cutter itself. I deliberately made it so the blade has to be removed and stored separately to reduce the chances of it getting rusted in place. And that's pretty much it for this one. Thanks for watching. I hope to see you next time.